or Hadoop installed on a cluster. Hadoop installed on a cluster. So as you know that we keep some data, or we write some data and read now data. Now how the file is being divided. So how the file is being kept on a cluster. So we have learned that any file that you wanted to keep on a cluster, that would be broken in the form of blocks, or in the form of chunks onto a cluster. So you divide the file, and each piece of data we call it as a block. So we will divide each file in form of block, and each block would be stored on your Hadoop cluster. So now here we are talking about block. Now what is a block? Block is a logical partition of the data that we are trying to keep on a cluster. So it would be divided as as blocks, and the memory, the size of that block in Hadoop is the size of that block. So all the files would be split, or whatever, broken, split in form of, or in the form of blocks. Now this blocks concept is not new. This blocks concept is not new in Hadoop. In GFS, in Google File System also, they have invented this concept of dividing the file in the form of chunks. So there we call them as chunks. In HDFS we are calling them as blocks. And each operating system, so again we have to get into a little discussion about the operating system. Each operating system, either it is a Windows operating system or any of the Unix flavors, you have so many flavors of Unix operating system, any Linux operating system, you have this concept of dividing a file into blocks. Now this block, always, every block has a size, Now the block size of Hadoop, the size of block, or the block size of Hadoop, the block size of Hadoop is 64 MB in 1x version of Hadoop, and 128 MB in second level, or 2x version of, or Gen 2 version of Hadoop. So 64 MB and 128 MB. So we will be looking at 120 MB sized block when we go to 2x version of architecture. So our only concentration here would be on 64 MB, as we are exclusively studying the details of Hadoop architecture or 1x architecture. Now the block size of Hadoop is 64 MB. Now what are the block size of different operating systems? What are the block size of different operating systems? Now 512 is the size of a block in Windows, and 4 to 8 KB in Linux or Unix. So if you see, the block size has increased drastically from operating system to operating system. Now what is the importance of increasing the block size? The more block size that you can have your processing that quickly and that fastly. So remember, there is a relation between the block size and the processing. So every file divided into certain set of blocks on which you do some processing, it also has a importance of how big your block is. So Unix, remember, that is one of the interview questions as well. So the block size of Unix file system is 4 to 8 KBs. Again, when I say Unix, block size of the file system would be different from the block size of the hard disk. Block size of the hard disk would be merely KBs, but here 512 it's only bytes, but here if you look at the block size of the file system, it is very high. So block size of Windows is considered to be 512, or block size in Linux considered to be 4 to 8 KBs. Now would you please compare the block size of Hadoop to this block size? So it has drastically increased from 512 to 4 KB to 8 KB, 4 KB to 8 KB, and our Hadoop has a block size of 64 MB, and the newer versions are 128 MB, and even the newer versions they are actually increased the block size as well to 512 MB. Probably in the future we would see the block size being 512. It's only depending on the variety or the amount of the data that you deal with. So here now the block size. Now block size is, why block size is so high in HDFS is one of the questions that we have to deal with. Why block size is so high in HDFS? Why block size is so high? So if you wanted to understand why block size, why block size is large or high in HDFS. To understand why block size is high, we need to understand a term called as seek time. Seek time. Seek time. Now what is a seek time? Seek time is the time taken to find a particular location of a data file on your hard disk. If I wanted to find any file on your hard disk, what is the time that takes inside the processor? That is called as seek time. Now in the computer world, in the world of computers, in the computing world, we consider seek time to be very expensive. So we do not tend to have seek time being very high. So in order to get that down, so once the seek time is low, that means you can find, once you find the data or once you find the file of the particular data you are searching for, the rest of the things can be done very quickly. So seek time is the time taken to find, time taken to do that particular file which you are looking for. That is called as seek time. So here what is the relation between the seek time and the size of the block size is, the more the block size you have, the less seek time that you can have. The more the size of the block is, the less seek time that you have. As we are saying, the seek time being very expansive, so we don't tend to have more seek time, or we don't tend to have more time only on the searching of particular file or particular data. No, seek time always has to be less, then the rest of the things fall in place actually. So seek time tend to be very less. So there is a relation between the seek time and the size of the block. So the more you have the size of the block, that is the reason you see in the Gen X 2 version of Hadoop we have the block size as 128 MB. So that is the reason we have the block size as so very high in HDFS. Now yes, we know what is a block. Now we know what are the different things on a cluster. So now we have studied about the master, okay, and yes, about the slave machines, we call them as data nodes, master node, or else we'll have written this something like this. We have a name node. Yes, we have a name node, right? So we have a name node and we call it as master node, which is expansive, which is of the server grade machine, and we have data node. In between we have secondary name node, we call it as an standby for the master, which is also it's also considered to be a master node. And we have data node, we call it as a slave machine or a worker machine or a commodity hardware, we call it as a commodity machine. Now we know what is a block and what is seek time, why the block size is so high, and what are the different sizes of the blocks in different operating systems. We have seen them. Now we would like to study one more concept on Hadoop architecture is Hadoop is designed for storage, Hadoop is designed for processing, and we can avoid data loss. Hadoop is designed in such a way that you can avoid the data. How do you avoid the data? So we can avoid the data loss. So how can I avoid the data loss? By implementing a concept called replication. By implementing a concept called as replication. Now what is replication? How do you define the replication? Replication will be defined if you have two copies of the same data, or any more than one copies of the same data, that is called as being replicated. Same data, you have one more copy. Now here Hadoop also designed in such a way that you have the factor of replication being implemented on Hadoop, and we all call that replication factor. So the replication factor of Hadoop is, replication factor of Hadoop is 3. That means whenever you place the data or a file on a cluster, that file would be broken into blocks, and each block would be replicated 3 times. Each block would be replicated 3 times. Now pictorially we will understand this. Now again, master node, that is the name node, and these are my data nodes. Now what I will do is, I will keep it here. These are my data nodes. Now I will keep the data, this is data. Now when I say, now I have a file of, or size of the file, let us say 3x. So what I will do, now name node, okay, this would be divided as, let us say, not 64 that we are talking about. Now to understand how actually the data being replicated. Now my file is of the file 3x size. Now what I am doing is, I wanted to place this on my cluster. So obviously, as I said, the file would be divided. Now to our understanding, to make our understanding a little easier, what I am doing is, my file 3x is divided as a 3 equal portions of 1x, size of 1x. So I will keep here and I will keep here. How you read and write the data, that is rack awareness, they will come to that, but to understand how the replication would happen. Now the replication, now 3 blocks have been placed on. Now the replication now comes into picture. Now this block, again you will have this here, this you will have again here, and this again you will have here and here. So 1, 1, 1, 2, 2, 2, third copy, 3, 3. So together you will have 3 replications of each block of data. This way we can avoid data loss. Let us say somehow this data node goes down, no problem, I will have the data again being replicated on the other node of other cluster. So rack awareness again comes into picture. How you write the data, whether are you writing the data based on the distance, or are you writing the data based on the availability of the space? Is that what the rack awareness is, right? Or you writing based, when you are writing it, when you are reading it, there are other things that would come into picture, the RAM speed of the RAM, and the availability of the node, and also the network speed, right? So when you are writing, or these are the 4 components that depend on rack awareness. One is when you are writing the data, whether it is close to the client or the distance, and the availability of the nodes, and the RAM capacity, and fourth one is the network speed, the fifth one is availability of the nodes, and the sixth one is whether are you placing the same information again on the same node. So these are the 6 things that would be considered when it comes to writing or the data. So here we are not talking about the rack awareness here, we are only discussing how your data being replicated. So how you can avoid the data loss. So pictorially, if you look at, if this data goes down, no problem, I'll have and here I can have that captured from other nodes of other rack. Now again you may ask me why to have 3 replications, why not 2, why not 1. We'll come to those, all those, you know, questions, why and why not, so in the coming sessions, right. So remember, the replication factor for Hadoop is 3, and that is configurable. It is not that you will have only 3. Generally 3 is kind of reasonable, you know, moderate number, 2 being very less, you know. 2, if you have only 2, probably, you know, 2 goes down, you will have the data loss. So 1, you have 1 more. You may ask me, all the 3 goes down, then what? So that actually would be actually taken, would be looked after by the Hadoop. That are the vague scenarios that all these things will not happen actually. So okay, to understand how the replication would actually go, this is how the replication. Now this is configurable. You can make it 3, 4 depending on the data that you're dealing with and the kind of infrastructure that you have. Okay, so it can be any number of replication that you have, but we don't willing to have those many replications. So replication factor is 3. Replication factor is 3. Why we have to have the replications is because we can avoid data loss. To avoid the data loss, we have the concept of replication here. Now I hope you understand the different, you know, things that would happen on Hadoop architecture. Now let us say if I wanted to write any file on the data or on the cluster, any file on the cluster. So I have a file of 100 MB. Okay. Now I have a file. First of all, what I'll do is I have a cluster of 1, 2, 3, 4, 5, 6, 7 and 8 machines. Okay, and this is my cluster. Just I'm trying to, you know, make you understand more on how what happens, how you write the data on a cluster, how you access the file, read the data on a cluster, what happens if certain nodes goes down, what are the different use cases, you know, we call what are the failure use cases that we can may face. So that things will look at now. So now let us say this is my cluster, okay, and my client is the one who actually wants to perform, can be a program, can be a machine, is the one who actually wants to perform something on my cluster. So I want to write a file, I want to store this 100 MB of data on this cluster. So obviously I'll have a master node here, isn't it? I have a master node and we call them as the data node. So how many data nodes I have? I have 8 data nodes and my cluster is this. Then my cluster is this. Okay, right. Now here I wanted to have dumped. Now I wanted to store the file. I wanted to write the file. I want to write the file onto the cluster. So whenever I wanted to write the file, what I'll do, the client would actually have a communication with the name node. Name node would tell what are the how much space available on the cluster and what are the nodes that are available for writing. That means what are the you know, on which nodes you have you know, free memory that data can be written on. So first, what 100 MB data would be, first it would be divided in form of blocks. Okay, so first this 100 MB of data would be divided in form of blocks or into blocks. Now this 100 MB we can divide it as the size of each block on this cluster is 64 MB. So this file would be divided as 64 and 100 minus 64 is 30, so 36. So 2 blocks, 64 is 1 block and that is equal to 100 MB. right? So 64, now this 100 MB file is divided in form of 2 blocks, that is the 64 and 36. Now I wanted to write this onto my cluster. So if I wanted to write any data onto the cluster, that's when the concept of rack awareness comes into picture. Rack awareness comes into picture. The first point in rack awareness, depending on, is the distance. We call it as the proximity, physical proximity of the node, how close my node is to the client. So it depends, the writing of data depends on the proximity. Proximity is, let us say, for this client, now physically speaking, now with this diagram, now these two are the nodes, very close. This is a little distant and this is very far. Okay, so you can have, if you write the client here, then these two become the closest, just to make you understand. Okay, now this client is closer to 1 and 2, these are the two machines, so distance is good, these are the two machines. Now it has to check for whether the space is available or not. Okay, now let's say these are closer systems and space is also available. So now the 64 would be written here and 36 would go onto the next node. Here writing of the data would happen parallelly. Writing of the data would happen. This is very important, guys. Remember, so we are writing the data onto the cluster. My first node go to my first machine, not the first machine because of its number. It is first machine is because of the distance between the client and the node, because of the proximity between the client and the node. So the first would take the block 1 and the second would take the block 2. So here when you are writing of a file on a cluster, would happen parallelly or parallel. Okay, parallel. So at a time you would see the file being written on node 1 and node 2. That's the beauty of distributed file system. So you will see now my block 1 is being written on the node 1, my block 2 being written on node 2. Now there comes the concept of the replication. Now I have the data on my cluster and I want to replicate it. Now let us say the immediately now how the replication factor would be done is, it only depends on the availability of the data for the replication. It depends on the availability of the nodes or availability of the space of the nodes for the replication factor to occur. Let us say I have my replication on, let us say there is no availability on number 3, immediately my replication would be done here. So from here again, from here to here, right. So for 3, let us say I'll make it here, and from here to here 36, and from here to here. If you observe, the replication happens always not parallelly but sequentially, because there would be a communication happening here. So I'm done here, now I wanted to have my data on here. So and from here the information would go to here. It's not that this will give information to this. No, remember, sequentially the replication factor would occur. So the writing the files on a replicated blocks would happen sequentially. So writing a file or on a replication or a replicated block would happen how? Sequentially. This is very important. writing the data on a cluster would happen parallelly, but whereas writing the data on a replicated, it's only depending on the availability of the nodes and the resources you have on the particular nodes of the cluster. So when you are replicating the data, that would happen sequentially and not parallelly. So this is how the replication, how data being read. Now as again said, lot of again this rack awareness, the concept of rack awareness would come into this picture, whether the how close is the system to the client. And when I say data center can be spread across different geographical locations. Let us say I want to write a cluster, I want to write a file, and my cluster is distributed across Hyderabad, Bangalore, Delhi and Bombay. Now if I wanted to write a file, what happens is, which is first thing it checks is who is very closer. So from Hyderabad, Bangalore is the closer. So immediately my file would be written on a data center which exists in Bangalore. So when it comes to replication, from Bangalore to Delhi would happen and Delhi to Bombay would happen. So if I wanted to do the replication factor is the proximity, the closest data center, and again the space availability, RAM, network speed and node availability, and also replication cannot be done on a same system time and again, right. So here if you look at, so here each replication happened on a different system. So replications cannot be done on the same systems, because that's not the whole idea, because to avoid the data loss always you have the replicated copy on a different rack of a different data center. Now this is what happens when you write the data on a cluster. So next is when you read the data. So next is again, if I wanted to, now I have one more client B who wanted to read the data, okay, read the data, okay, or access the data. I wanted to access the file. Now here I am sitting, okay, yes, this is the master node, of course, master, and my client is, let us say, here. Now my client B is here. So while reading the data also, again the same things would come into picture, the distance. Now here, which is the closest to my client B? Yeah, this is the closest. So the reading of the file would start from here, okay. So reading of the file would start from here. That's how you'll have the data being replicated or data being loaded on the cluster. That is how you read the data and you write the data. So this is what the few details of Hadoop architecture. So we have, as I said, this is the architecture. This is the architecture of 1x version, and this is the architecture we will be looking at the architecture of 2x in the coming classes. So the beauty, there is lot of things that we can experience. So once you install Hadoop onto the cluster, we can see the replication factor being done immediately. All these things will not do all this, breaking of the file or the replications, we all not do. We'll only see the framework will take care of. Now there are certain things that we have to consider when writing the data or reading the data. Now let us say we'll see some failure use cases.